Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over part 8, problems 36 to 40 of the ACT Math Prep Released questions. These documents can be accessed at www.actstudent.org. Alright, let's take a look at question 36. It reads, which of the following is the graph of the region 1 less than x plus y less than 2 in the standard xy coordinate plane? So we have 5 options here. Now before we get started, let's take a look at the formulas that guide our process of graphing linear inequalities. Okay? Alright, so if you have y is less than mx plus b, what this basically means is that you're graphing a broken line where the top is shaded. You shade the bottom, shade downwards. So less than means shade down. And then when you have y is greater than mx plus b, you have a broken line. The slope is m, the y-intercept is b, and then you're going to shade upwards. Okay, so let's state that also m is the slope, and b is the y-intercept, where you start graphing your slope triangle on the y-axis. Okay, now it's easy just to graph one linear inequality. In this case, we have a compound linear inequality, okay? Or a system of linear inequality that has been condensed into one. So we have 1 is less than x plus y is less than 2. So in order to graph this system of linear inequalities, we will have to separate them. Okay, we have to break them into two, put them in the y less than or greater than mx plus b form, and then we can graph after determining m and b. Okay, so how do we split this up? We are going to split them up into inequality 1, which we compose of the left side and the middle. That will form inequality 1. And then inequality 2 will be formed by taking the middle and combining it with the right side of the compound linear inequality. Call that 2. Okay, so let's go ahead and take a look at both of them individually. So let's start with linear inequality 1. For linear inequality 1, we have 1 is less than x plus y. Now our goal here is to get y isolated so we can know what the slope is and also the y-intercept and how to shade. To get y isolated, we will subtract x from both sides, subtract x, and then you have 1 minus, or we can write this as negative x plus 1 is less than y. Okay? Negative x plus 1 is less than y. Notice that the inequality sign is pointing towards the negative x plus 1. So that means y is greater. So we can switch this inequality notation around. So this is equivalent to y is greater than negative 1x plus 1. Okay? So what does this tell us? Well, we already have it in y is greater than mx plus b form. It tells us that the slope m is going to be negative 1 over 1, which means we're going to fall 1 and run 1. Falling 1 is the negative rise. Where are we going to start? What's the y-intercept? The y-intercept b is positive 1. Okay? Now let's take a look at the linear inequality 2, which is x plus y is less than 2. The goal here is to get y isolated. Let's go ahead and do that. We'll subtract x from both sides. That yields y is less than negative x plus 2. Alrighty? Now from here we can, let's write it in mx plus b form. Y is less than negative 1x plus 2. In this format, we can clearly see that m is negative 1 over 1. So you rise negative 1 and run 1. B, your y-intercept, is 2. If you take a look at these two lines, what do you notice? They have identical slopes. They both have a slope of negative 1. So they are going to be parallel because if two lines have the same slope, they'll be parallel. We have two lines that are parallel and have y-intercepts of 1 and 2. Okay, let's go ahead and write that down. So we have two parallel broken lines with a y-intercept of 1 and 2. Okay, for the first one, inequality 1, you're going to be shading upwards. Inequality 2, you're going to be shading downwards. Okay, but that's something to keep in mind, but it doesn't really help us to figure out the question, the answer here. This information we have should be enough for us to figure out the answer. Okay, so let's see. All of them are parallel. All the options are parallel, so that doesn't help. But the fact that they both have so we have two parallel lines two parallel broken lines with y-intercept of 1 and 2 and a slope of negative 1. Okay, so that's important. Which lines have negative slope? Remember the orientation of your slope. From left to right, if a line is going down, it has a negative slope. Okay? From left to right, if a line is going up, it has a positive slope. So whichever parallel pair of lines that are going upwards from left to right, those should be eliminated. Okay? Left to right, this is positive slope here. So that's not an answer. From left to right, this is good. From left to right, this is going up, positive slope. This is not the answer. This is negative. This one also has a negative slope. And H has a positive slope, so that cannot be the answer either. Now, what's the difference between these two lines or system of inequalities? The difference is the y-intercepts. Okay? For option K, your y-intercepts are negative 1 and 2. Right here, that's your first one, negative 1, and your second one is 2. For this pair, your y-intercepts are what? 1 and 2. Look at what we have here. Which one is the correct one? In this from this result that we came up with, we saw that the y-intercepts are negative 1 and 2. So the correct answer is option letter K. Alright, let's take a look at question 37. It reads, what is the difference between the mean and the median of the set 3, 8, 10, 15? Alright, so let's go over our formulas before we get started. We have two formulas that we need to call to mind. The mean formula is sum of numbers divided by what? Sum of numbers divided by the number of numbers. How many numbers do you have in the set? And then median is the middle number or average of middle pair. So you have a middle number when you have an odd number of elements in your data set. Okay, you have to average a pair when you have an even um, number of elements in your data set. So middle number or average of average pair of middle or average of um, middle pair. This happens when you're dealing with even numbers. So you look at a middle number or average of middle pairs um, when arranged in um, ascending um, or descending order. It doesn't really matter as long as this order is sorted either by from smallest to biggest or biggest to smallest. Okay? Alright, so let's go ahead and start off by looking for the mean. Um, so for the mean here, we are going to look at the sum 3 plus 8 plus 10 plus 15. And we're going to divide that by the number of numbers. How many elements do you have in this set? You have 4 elements. Okay? So if we add them all up, 3 plus 8 plus 10 plus 15 is 36. Divide that by 4, and your mean value is 9. Okay? You notice you have a 9 as an option here. That's a distractor. Remember when you're taking the ACT, make sure you answer the question. The question is not asking for the mean. It says what's the difference between the mean and the median. This is just an intermediate answer. Okay, now let's find the median. So the median of this set 3. The nice thing about this data set is that it has already been sorted for us in ascending order from smallest to biggest. But since we have an even number of elements here, we are going to look at case 2, which is the average of the middle pair. So we have two numbers. So we just take the mean of the middle pair, okay? Or you average them out. So your median in this case is going to be 8 plus 10 divided by 2. 8 plus 10 divided by 2 is 18 over 2, which is 9 again. So difference between mean and median is what? Is given by 9 minus 9, which is 0. Answer to question 37 is option letter A. Alright, let's take a look at question 38. It says, which of the following describes a true relationship between the functions f of x equals x minus 3, quantity squared plus 2. That's the quadratic function. This is f. And the linear function g of x equals 1/2 x plus 1. Graphed below in the standard xy notation. So f of x equals g of x for exactly two values of x. F of x equals g of x for exactly one value. G of x is less than, f of x is greater than, or f of x is the inverse of g of x. Okay. Now, something you want to remember when solving an equation involving equating two functions. So recall, two functions are equal for the x values of their points of intersection. Okay? So two functions are equal at the x values of their points of intersection. It could be a point or it could be multiple points. Okay? So if you want to solve the equation involving two function sets equal to each other, the x values that satisfy that equation are equivalent to the x values of the points of intersection. Okay, so look at option F. G of x is equal to f of x is equal to g of x for exactly two values. So the question is, how many points of intersection do you have here? For option F, I'm just going to sketch it on the right side right here. For option F, you have a scenario where you have 2 points of intersection. Okay, so you have your quadratic and your linear. You have an intersection here, and you have an intersection there. 2 points of intersection. So if you have 2 points of intersection, that tells you that you're going to have two x values that satisfy the equation. Okay, so two x values. They mean the same thing. Equivalent statement. So the answer is option letter F. Okay, now let's take a look at the other ones just to help you understand exactly what's going on here. For option G, you have f of x equals g of x for exactly one value. What does that look like graphically? You have a scenario where you have exactly 1 point of intersection. Is that possible in this setups? It certainly is. It happens when you have a situation where exactly 1 point on the line intersects the graph. Okay, it's just like a point of tangency. So you have something like that. Oh, I'm going to move my line up a little bit. So it's just like a point of tangency right there. So you have 1 point of intersection like this. Here you have one x value. Okay, so this is correct because that matches the graph. This is wrong because we see that this is a secant line. It's not a tangent line, so this is not the answer. How about option H? Option H says f of x is less than g of x. What does that look like? Well, it's impossible for that to happen. F of x is less than g of x is basically a scenario where the graph of f in the entire domain resides underneath g. That's not possible in this setup. But let me just give you an example that illustrates that comparison. So in this case, we have to change the opening of f into a downward orientation so it never crosses g. So you have f right there, and then you have g somewhere above it, like that. So in this setup right here, f of x is less than g of x. Okay? And we can clearly see that this is not the answer because the graph that we have does not match it. Now let's look at option J. What does that look like? Let's give ourselves a visual. A scenario where f of x is greater than g of x. Can you visualize what that looks like? Is a scenario where the function f, the quadratic, is above the line for the entire domain. Okay, so you have the quadratic and then you have the line. Beneath it, we can clearly see that option J is wrong because the lines do intersect at 2 points. F is not above J. Okay, and then K says F is the inverse of G. Well, what does that look like? Inverse basically means that the two graphs are mirror images of each other along the reflection line y equals x. Okay, so let me give you a visual as to what that looks like. So if we have, let's say we have f. If this were f right here, um, g will not be a function because f does not pass the horizontal line test. So its inverse will fail the vertical line test. So g is not going to be a function, okay? But let me just show you what it looks like. So if that is f, what you have is a mirror. The mirror is the line y equals x. And then you basically reflect this line about this horizontal line. This diagonal line right here. If you carry out that reflection, it's going to look something like this. Something like that. Okay, it's not a perfect sketch. It could be better. Let me sketch it again. It's just to illustrate what the inverse looks like. Okay. If you draw it using coordinates, then your graph will be much more accurate. So it's just a sketch of what the inverse looks like. The inverse is the reflection along the line y equals x. So this is f, and that's g, the inverse. So if you take a look at f and g, one is linear, one is quadratic. They're not inverses of one another. So we can clearly see that option K is not the answer to this question. Alright, now let's take a look at question 39. It says, what is the slope of segment CD? In the instructions early above this, it says that this is a trapezoid. Okay? Alright, so what's the slope of CD? To do that, we're going to start by taking a look at the formula for the slope of a line segment. So let's go ahead and write this down. The formula for slope. Slope in coordinate format is given by m, which is y2 minus y1 over x2 minus x1. Okay, so we're looking for the slope of CD. So we need C. Point C is 9, 4, and point D is 12, 1. So let's see. The first point will have x and y with 1 as their indices, so x1, y1, and then the second point will be x2, y2. Alright, the reason why you want to label your points is that it helps you avoid making mistakes when you're substituting your values into your formula. Okay? So the the ones are the first and the twos are the second. Now we are ready to compute the slope of segment CD. Now, that's not a coordinate grid. Okay, so let's do it. The slope of CD is given by y2 minus y1, 1 minus 4, divided by x2 minus x1, 12 minus 9. You have negative 3 over 12 minus 9, 3. So you have to be really careful with your signs here, okay? So your answer is going to be negative 1. The answer is option letter B. Now, let's say we made a mistake with the signs and we ended up with positive 1. We have a distractor right here, option C, that will get us trapped. Alright, so please be careful with your signs when you're calculating slope. Any calculation at all, just be careful with your negatives. Alright, let's take a look at question number 40. It reads, when ABCD is reflected over the y-axis to A prime, B prime, C prime, D prime, what are the coordinates of D prime? There are two ways you can do this. You can either do this graphically using the graph of the trapezoid and just reflect the point, or you could do it using arithmetic. Okay, what I'm going to do is I'll show you the two ways of doing it. Let's take a look at the arithmetic approach first, and then we'll do the same problem graphically. Okay, if you want to do it using the arithmetic approach, we have to take a look at what the formula is first. So the formula for reflecting a point on a 2D coordinate system just involves manipulating the signs of the coordinates. Okay, so if you're reflecting about the y-axis, what happens to your original point or your object point xy is that you negate the sign of the x coordinates, and that will result in the reflection about the y-axis. Because if the y is a mirror, the x is going to be the one that gets reflected. Okay? So let's do this. So we are reflecting about the y-axis. We are reflecting point D on the trapezoid. So that's the trapezoid for you there. So we are reflecting point D. Point D, we just need a coordinate pair for point D. So point D is 12, 1. So if we reflect this point about the y-axis, all we just have to do is take the opposite of the x coordinates, which would take us to the image d prime, which would be negative 12 comma 1. Answer is option letter, let's see, F. Bam. Okay? Now let's do this using our graphical approach or geometrical approach. Okay? So graphically, um, you just have to visualize what's happening here. Okay? If you have a point, so let's say this is my y coordinate and this is my x coordinate right here. Point D is 12, 1. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 1 is right here. That's point D. That's the only point I'm reflecting, so I don't have to draw the entire trapezoid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so when you're reflecting about the y-axis, what is going to happen is that you are going to carry out a reflection. You're going to go in the opposite direction. Okay? Um, your distance from your y-axis, you travel in the same direction. I mean, you travel the same distance, but in the opposite direction from your y-axis. So this is your original point right here. Okay? So your original point is, let's make this blue. So your original point goes from here, okay, 90 degrees perpendicular to the y-axis. Okay, so we're going to go perpendicular to the y-axis with the same distance in the opposite direction. That's what the reflection is. You're traveling the same distance in the opposite direction perpendicular to your mirror. Okay, so what we're going to do, guess what? We're going to travel um, 12 units in what direction? To the left. Starting from the mirror, the y-axis, this point right here, you go 12 units in the opposite direction. That's the reflection about the y-axis. Okay? You start from the base, where the point, uh, the, the place where the point meets the traced line to the y-axis, that's where you start your reflection from, okay? And you count from there in the opposite direction. The coordinates of this point is the answer that we're looking for. So this is 12, 1. This point right here is D prime. What are the coordinates of this point? Notice it is only the x that changed because we're on the same horizontal line, the same y value. So you have negative 12, 1 as your answer, and that matches perfectly with what you have here. So you can use the arithmetic approach or the graphical approach. The thing about the arithmetic approach is you must remember the formula. If you do not know what the formula is, don't even try using this method. Just look at it graphically and then just mirror your points and you should be able to get the correct result. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the ACT, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel at mathgotserved.com, right at the YouTube page for mathgotserved.com. If you want to get updates to other tutorials and the remainder of this review series. You can also visit our website at mathgotserved.com for formula sheets to help you with the ACT and other prep resources. Thanks again for watching and have a wonderful day. Goodbye.